Today we're going to learn how to write the full equation of the line through 2 points. So we've already seen how to calculate the slope between 2 points. Now we're going to put it into the equation of a line. Here is my version of point slope form. What I taught you when we were graphing was the real version of point slope form. I like to partially solve it by adding that y1 over to the right hand side. When I taught you point slope before, the y1 was on the left. Everything else is the same. I just add that y1 over so that the ordered pairs are both on the same side of the equal sign, and then I use an asylum analogy. When people go to an asylum, it's because they don't act normal. They don't do what you expect them to do. These parentheses, or these grouping symbols in the equation, act like an asylum because when you put the x1 in, it's not normal. It becomes opposite. It doesn't do what you think it should do. But then the y1 is on the outside, and it is normal, so it does do what you expect it to do. We'll see how this works when we get some real numbers. Our essential question today is how do we write an equation given 2 points? Starting off by calculating slope, remember change in y over change in x, or y2 minus y1 over x2 minus x1. It does not matter which ordered pair you call x1 and y1, and which one you label as x2 and y2. With my choice, I am going to do 4 minus negative 2 over 2 minus negative 1. Adding the opposite in both the numerator and the denominator, we get 6 over 3, or 2 for our slope. Then we set up that point slope form, y equals m, x minus x1 plus y1. Now that x1, y1 does not have to be the same x1, y1 we chose, but if that helps you organize your equation, go for it. Substituting in that slope that we just solved for, x and y remain variables. So here's how we're going to use my asylum analogy. That x1 goes into the asylum and becomes opposite. So looking at my negative 1, I put it into the parentheses with the x and it became positive. My y1 is outside the asylum, so it stays normal. It is negative, it will stay negative. And then we put it into slope-intercept form by distributing our slope. So y equals 2x plus 2 minus 2. Combining those like terms, the 2 minus 2 cancels, and we're left with an equation of y equals 2x. We're going to repeat this process a few more times so that you can hopefully get the hang of it by the end of this video. Slope is y2 minus y1 over x2 minus x1. Switching things around this time, I'll call this x1, y1, and we'll have this be x2, y2. We've got 3 minus 0 over 4 minus negative 2. 3 minus 0 is 3. 4 plus 2 gives us 6. And we'll simplify our slope to 1/2. Setting up our point slope form, y equals m, x minus x1 plus y1. Substituting in that slope of 1/2, leaving x and y as variables. Once again, my x1 is negative, so it's going into my equation and becoming positive. And my y1 is 0, so that will stay normal. Distributing my slope, we get y equals 1/2 x plus half of 2 is 1. And adding on that 0 doesn't change anything. So my equation is y equals 1/2 x plus 1. Let's practice that again. We've got our x1, y1 and x2, y2. Slope is y2 minus y1 over x2 minus x1. We have negative 4 minus negative 5 over 4 minus 0. Subtracting a negative, we'll add the opposite. Negative 4 plus 5 is 1, and 4 minus 0 is 4. So our slope is 1/4. Substituting that into our point slope formula, x and y are variables. Our slope is 1/4. x1 in this case was 0. goes into the asylum, but 0 isn't positive or negative. So in this case, you really could put a plus or a minus sign on that. The y1 stays outside and stays negative. It's normal. This one we could either distribute or we can use order of operations because x minus 0 is just x. So we get 1/4 x minus 5. This example, I'll switch things around again. So this one is my x1, y1. And the first one is my x2, y2. Order does not matter when you're labeling your pairs. Slope is change in y over change in x. In the numerator, we have -3 minus -3. In the denominator, we have 3 minus 6. In the numerator, adding the opposite, -3 plus 3 is 0. 3 minus 6 is -3. 0 divided by anything is still 0. We're going to get a special line on this when we get a slope that is 0. So let's see what happens when we set up our point slope form. Y equals m x minus x1 plus y1. Substituting in that slope of 0. My x1 is +6. It goes into the asylum and becomes opposite as a -6. My y1 stays outside and is normal at a -3. We could distribute the 0, but we have 0 times all of this. 0 times anything, no matter what it looks like, is still 0. So all of that goes away, and I'm left with y equals -3. Some of you may be able to tell by looking at the ordered pairs that we have a special line. Remember when we set up those t-charts and we substituted the same value in for y when we had a special line? When you look at the ordered pairs, if both of your x values are the same or both of your y values are the same, you're going to end up with a special line, and you can skip finding the slope and you can skip point slope form and you can simply write y equals or x equals. If you're not that observant or you're just getting in the habit and you just always start with slope, your slope can give you a clue to the special lines as well. So let's look very closely at this last example. We have an x value of 8 for both of our ordered pairs. This is a special line. X equals 8 is our equation. And you have 2 U-try questions.